Lisa has $240 in her savings account. She spends $20 per month on a gym membership. Tom has $360 in a savings account. He spends $30 per month on a gym membership. When will Lisa and Tom have the same amount of money in their savings account? This is a real life application problem in which you can write and solve a system of equations in order to figure out when Tom and Lisa will have the same amount of money in their savings account. Whenever answering a word problem in which you have to write and solve an equation or a system of equations, you should always be looking to identify the independent and dependent variables within the context of the problem. You can see here that I have already written out what the independent and dependent variables are in the problem. The x, or independent variable, is the time, which is in months, and the y, or the dependent variable, is the amount of money in the savings account. We also want to look for the rate of change, which is the unit rate or the slope. And we also want to look for the initial value, which is the y-intercept, or the b in the equation. Lisa has $240 in her savings account, is highlighted in yellow. So is the b variable, which is the initial value. So Lisa's initial value is $240. Tom starts off with $360 in his savings account. So that is his initial value. The m, as you recall, in the equation y equals mx plus b, is the slope. It's the rate of change. It's the unit rate. And I highlighted Lisa's unit rate and Tom's unit rate in green. Lisa spends $20 per month. The per month is what gives it away, that it's the rate of change. Since she's spending money, her slope is going to be negative 20. Tom is spending $30 per month, so his slope is going to be negative 30. Now we can go ahead and we can write an equation for both Tom and Lisa. Lisa's equation, since the amount of money depends on the amount of money she is spending per month and the initial value, this is her equation. Tom's equation would be this. If we're looking to solve a system of equations to figure out when they will have the same amount of money in their savings account, we are going to use substitution, and we are going to substitute this value of y in for y and end up setting the equations equal, or the expressions, I should say, equal to each other. Now we have an equation that we're going to end up solving in terms of x, which when we do solve, we'll figure out the number of months when they have the same amount of money in their savings account. Since we are being asked to figure out the time, and time is the x variable, we just figured out that in 12 months, they will have the same amount of money in their savings account. We were not asked how much they will have in their savings account, but if we wanted to know that information, then we can take this value of X, which is 12, and we can plug it back into one of the equations to figure out how much money they will have after 12 months. So let's just go ahead and do that, even though they didn't ask us for this information in this context. It's also always good to solve for both variables because then you can actually use it to check to make sure that your solution is correct. So we're finding that in 12 months, they will both have $0 in their savings account. We do want to always make sure that we are writing our answer in context. So we do want to make sure that we have the answer to the question, which is in 12 months, Tom and Lisa will have the same amount of money in their savings account. We do want to make sure that we check our solution in both original equations. So even though we solved for y here, sometimes students think that this is a check, but it's not really a check. It's just solving for y. So let's take both coordinates. Y is 0. And I'm showing the check because it'll help with other problems in which there isn't a context and you just have to check your solution. I think that some of the teachers have been commenting that the check needs to be the solution, which is the coordinate. The solution has to be checked in both original equations by substituting in the x and y values at the same time and making sure that the equation balances.